This problem is related to the concept of minimum deviation through prism, and problem says two equilateral triangular prisms P1 and P2 are kept with their sides parallel to each other in vacuum as shown in the figure. So, this is one prism and this is another prism. This is P1 and this is P2. This side and this side are parallel, and this system is kept in vacuum, that is refractive index of 1. A light ray enters prism P1 at angle of incidence theta such that the outgoing ray undergoes minimum deviation in prism P2. So, this light ray enters at this point in prism P1, and then we will have refraction and then further refraction, and then finally it will enter into P2, and question says in prism P2 this light ray experiences minimum deviation. If the refractive indices of P1 and P2 are root 3 by 2 and root 3. So, this has a refractive index of root 3 by 2 and this has a refractive index of root 3. Then theta is given by this expression which has a quantity beta. So, what is the value of beta? That is what we have to find. So, let us try to solve this problem. Now, first thing is in prism P2 light ray undergoes minimum deviation. So, what is the condition for minimum deviation? That we have to find. Let us say this is my prism P2 and this light ray enters at this point, let us call this point P, and then refract and then further refract and goes like this. We can draw a perpendicular on this surface, and similarly on this surface I can draw another perpendicular, and if I extend these two perpendiculars they meet at point Q, and this point is S, and this angle is prism angle which is often called as angle A. Let us say on this surface this angle is R1 and this angle is R2. So, for minimum deviation the condition is angle of refractions are equal, that is this angle and this angle is equal. So, this is a condition for a minimum deviation. Basically this ray is parallel to the base, and you can use all this and you can derive that this angle and this angle is equal in case of minimum deviation. So, R1 is equals to R2. Now, what about this angle? If you consider this triangle, sum of all the angle is pi, that is 180 degrees. So, this means this angle is 180 minus this angle plus this angle, that is R1 plus R2. Now, if you consider this quadrilateral, this angle is 90 because this is 90, this angle is 90, so this angle has to be 90. So, this means 90 plus 90, that is 180. So, sum of this angle plus this angle has to be 180. This means angle A plus angle PQR is equals to 180 degree. So, from here I can say angle PQR is equals to 180 minus A, and this is equals to this. So, this means R1 plus R2 is equals to angle A. So, this is another condition that I have. Now, what is angle A? Because this is a equilateral prism, so angle A is 60 degree. This means R1 plus R2 is equals to 60 degree, but I know R1 equals to R2, so let us put R2 is equals to R1. So, 2R1 is equals to 60 degree. This means R1 is equals to 30 degree, which is also equals to R2. Now, let us consider the original problem. So, this is the condition that we derived for minimum deviation. Now if I have both prism, that is P1 and P2, refractive index for this is this one and this is this one, and this enters here, and we derived that this angle is 30 degree, that is R1 is equals to 30 degree. Now I can use this to solve this problem. So let us apply a Snell's law. What is this law? This law says n1 into sin theta 1 is equals to n2 into sin theta 2. This means I can apply a Snell's law at this point, and this point, and I can solve the problem. So let us first apply a Snell's law at this point, because I know this angle and I know the refractive index, then I can calculate this angle. So if I apply a Snell's law at point C, I can write 1 times sin alpha, that this angle is alpha, so 1 times sin alpha, refractive index here is 1, and this is equals to root 3 times this angle, sine of this angle, that is sin 30 degree. So from here I can write sin alpha equals to root 3 and sin theta is 1 by 2, that is root 3 by 2, and root 3 by 2 sin alpha is root 3 by 2, this means alpha equals to 60 degree. So now I know alpha, that is this angle is 60 degree. So if I know this angle, I can calculate this angle. How? By using a Snell's law at this point. So let us apply a Snell's law at point B. So I can write refractive index of this prism times sin R2, that is this, and this is equals to 1 times sin alpha, but alpha equals to 60 degree. So from here I can write sin R2 is equals to sin 60 is nothing but root 3 by 2. So root 3 will cancel, and root 2 will cancel with 2. So I will have 1 by root 2 left here. Sin R2 equals to 1 by root 2, this means R2 is equals to 45 degree. So now I know this angle, that is 45 degree. But if you remember, this angle plus this angle is equals to this angle, because R1 plus R2 equals to A, and that is condition of a prism. So we can basically calculate R1. So if this is 45 and this is 60, this means R1 is 15 degree. Let us apply a Snell's law at point A. I can write 1 times sin theta, that is refractive index this side is 1 and angle is sin theta, and this is equals to refractive index times sin R1. We have already said this R1 angle is 15 degree, because R1 plus R2 is A, and which is equals to 60 degree, and R2 is 45 degree, this means R1 equals to 15 degree. So now I can plug R1 equals to 15 degree here. So this is the condition. So from here I can write theta equals to sine inverse of all this, that is sine inverse this, and 15 degree I can write pi by 12. So this means this value is what? This value was beta. So in this case beta is equals to 12. So I hope you enjoyed this problem, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.